Hey, okay, so let's just go over the questions here. If you could briefly give what your view and definition of biohacking is. Well, biohacking is a big umbrella term that has kind of several silos in it. There's genetic engineering, like changing DNA, RNA, like gene therapies, that kind of thing. There's kind of tissue printing, 3D organ printing, all that kind of stuff, regenerative medicine, that kind of thing. And then there's like lifestyle hacking where it's like changing, your diet or your behavior through meditation or other types of kind of lifestyle changes that improve your performance. And then there's the what we're doing, which is the direct augmentation through implantation of devices. And kind of all of them are how they fall under biohacking is that if you look at the word hack in a like as a negative connotation, like you're breaking something or whatever, then it doesn't make sense. But if you realize that in this context, hack means an unconventional approach or unconventional solution, right? So just by being unconventional, then it's a hack. And if you look at it in terms of biology, then it's a biohack. So it really just has to do with the fact that there are these edges of knowledge and edges of the envelope that are being pushed in each of these kind of silos. And it's just because that they're on the edge that they are a biohack. But often, what happens is if you have a hack, right, it becomes conventional, it becomes normal if that hack is effective or efficient or better than the convention, and then it becomes the convention. Then you have to push the edge or they push the envelope a little further, and that's where the biohackers are. They're always on the edge. Um, let's see about the next one. What do you feel the future of implant biohacking? The future of implants, I think, really comes down to getting better, like everything, like every tool that we use, smaller, safer, more features, right? So being able to do more with it. And I think we're going to start seeing implants that begin to integrate sensory data from biological processes, either, the simple stuff like temperature, heart rate, pulse oximetry, maybe glucose or other metabolites. There's other things going on in the body, cancer markers. Who knows? Like there's a lot that could be done there. And then once we start getting into biological integrations, like being able to talk to neurons, for example, you could have Neuralink, for example, in the brain, or other things like prosthetics controlled by actually having nerve ends that interact with the digital aspect of controlling a prosthetic. It could just go. There's a lot of places it could go. Um, so yeah. Let's see. How safe is it currently? Well, I mean, it depends on what kind of things you're talking about, but for us, chip implants, the things that we design, manufacture, and sell, it's very safe. And in fact, it's safer than getting an ear piercing. So if you look at like an ear piercing, you put a piece of metal through two holes and it just hangs there for days on end while the body tries to heal around this piece of metal. That whole time it's at risk of infection. There's keloid scarring. There's all kinds of problems that could develop. Whereas you look at, I mean, and then also, depending on the jewelry, if you choose bad jewelry, none of the jewelry is FDA approved or checked for quality really by any government agency. So, if you choose something bad, it could corrode, it could cause metal toxins, it could cause all kinds of problems. And so, but we consider ear piercing, just send your 2-year-old kid and, at the mall or something. So, it's actually much safer. You get an implant, a chip implant that we've signed, we've tested it. We've put all our tests online, the things that we've subjected our implants to and the tests we've done. It's injected with an injector, so it makes a little injection puncture wound, and that's over in a few seconds. You're done. Put a Band-Aid on it. Within a couple hours, that wound is scabbed over and dried, and then you can wash your hands, take a shower. The risk of infection at that point drops to almost nothing. So, that in itself is just safer than even an ear piercing. So it's extremely safe. But when you start talking about devices that other people are just making for themselves, we kind of step into this like self-experimentation realm. And so, I think there's a there's a really wide range of safety when it comes to those kind of devices. Um, because when you're doing something, anybody who works in software or hardware or anything, when you make something for yourself, you make it to work, and when you need to take that to product level to provide to other people, there's a ton more stuff you have to do and a lot more care has to be taken for safety. For example, like you might a lot of people might not realize, but if you make an implant device and you're packaging it up and you're putting it in a pouch or whatever you're putting it in, and you put it through sterilization, that's great. It'll come out sterile, assuming that all your apparatus is correct. But if you ate a peanut butter sandwich before that and then put peanut oil all over it, the sterilization process is not going to remove that peanut oil. So if somebody gets it who has a severe peanut allergy and they put it in their body, it could be very, very bad. So there's just an exponential level of quality assurance, forward thinking, safety forethought, all this stuff that has to go into when you actually produce products versus something you're going to experiment with on yourself with, right? So there's kind of two answers to that. I think it really depends on if you trust who you're getting your devices from, that they've done that due diligence and that that extra level of safety and care in production. So how safe do you feel it will be in the future? Cyber attack against someone's mod. So cyber attack is a whole different thing about like what I usually get the questions about safety. In the future, people are always going to do crazy things on the edge, and we just, kind of established that biohacking is always on the edge. So, for what we're doing, I started Dangerous Things in 2013. That catered specifically to biohackers, early adopters, literally bleeding edge, hackers. Now we're launching, well, we've launched VivoKey, and we're focused more on the general market because very quickly over that time, the type of customer has changed. And so VivoKey is very much a kind of a plug and play product. It is something that is clearly not a biohack, right? And it's a innovative solution, but it's moving into that realm that's out of the hacking and into the kind of conventional, boring, but safe. And so, VivoKey products are all cryptographically secured. They are protected against, cyber attacks specifically because they must be secure. We talk about chips that are like RFID chips or NFC chips that Dangerous Things sells, the basic chips. They're not meant to be secure devices, and they're not secure. And in fact, when you use them in a personal scope like your front door, the front door just reads the serial number of the chip. It doesn't really do any cryptographic checks or anything, so it'd be very easy to emulate that chip ID to the door and open it. But because it's personal scope, it's the risk of that happening is extremely small because it's your front door. And when you start talking about cyber attack or something like that, it is usually, well, almost exclusively random and also impersonal, meaning they're not targeting you specifically, they're just targeting any vulnerability. You might get swept up in that, right? In that kind of data collection or something. So in a personal scope context, if somebody were to, for example, set up a big reader and you would happen to walk right by it and they got your serial number on your chip, it's really useless to them because they don't know who you are, where you live, what that number means. It's useless to them. So personal scope has this mitigating factor. But when you start talking about business integrations like payments, banking, logging into websites where cyber attacks could happen, um, just basic business applications outside of that personal scope. You want to expand the scope, you have to be secure. And to do that, VivoKey uses chips that are specifically designed to be secure elements, meaning that they're not a general computing platform like a smartphone that has a ton of holes, security risks, and also the user loading all kinds of apps from who knows where on. It is a chip that does a very exclusive and specific job of cryptography, key management, all that stuff. So that its attack surfaces, the vectors you could use to attack the chip are extremely limited. All of them would have to be localized, meaning you have to physically be there. And none of them will succeed because they're designed to be secure and they're tested against that all the time. They're used for passports and payment cards and all kinds of stuff. So usually where you see breakdowns happen is outside of that, the chip itself. You see the applications, the way the bank implements security, for example, is terrible. So people are able to work around in some instances, those kind of things. So as long as the application development is great and the chip implants are going to be secure, at least the VivoKey chip implants will be. If we talk about, I mean, you could start going into like medical devices that have a terrible track record of being secure. And those are FDA approved devices, so definitely not biohack devices, but security is usually an afterthought in that realm, and yeah, it's just terrible, terrible track record. Um, oh, let's see. What is your ethical stand on implants? Um, well, that's kind of a huge question because it's so many. There's so many parts that you could break that down into. Um, my ethical stance on implants is like, don't make a bad implant. Don't make one that's dangerous. Don't make one that's poorly constructed. Don't make one that's going to hurt people. Make implants that are well designed. Make implants that are safe and tested and like, if not regulated, at least well tested. And yeah, so manufactured to a standard that is under repeatability, quality standards, all that kind of stuff. So anyway, we put all our testing stuff online. You can access all the tests that we do to our implants to see what we tried to do. And we've actually tried to destroy them in certain ways and have actually failed. So we hit our XNT implant with a EMP, for example, and it actually there was such a strong magnetic flux that it pushed, like launched the chip off the little EMP blast zone, and we had to put a cup over it to contain it, and it still read fine. So it didn't blow up, and it was functional after. So like it's pretty amazing what kind of tortures you can put these things through. But I think I don't know, ethical stance. It's a very broad question, and it's hard to answer. Um, Next one. Do you feel the same about gene therapy? To be honest, I really don't know enough about gene therapy to know where the lines are, like what the risks are and where those risks kind of come into play. But yeah, I think it's the same. If you're going to self-experiment, good for you. If you're going to share that information, share the information. If you're going to make product, whether it's research samples or finished, anything that's a finished thing, and give that out or hand it out or sell it, that's an order of magnitude different risk factor for everybody involved. The amount of effort and um, quality assurance that needs to go into something like that is exponentially high from versus doing something that's just an experiment for yourself. Um, yeah, I just don't know enough about it specifically to make any intelligent calls, but I would say that it's similar to device making. Don't make a gene mod that's going to hurt anybody. And if you're unsure or if you don't have quality checks or controls in place, then keep it to yourself. Yeah. So that looks like it.